So we're going to return to example 1. So what we did last time is we set up the linear program for example 1. So as you recall, here is our linear program. All right, that we're identified our objective function and identified our constraints. And now the question is, we want to know, how do we actually solve this out? All right, and we're going to do this graphically first. So let's go ahead and think about these constraints. And we're going to think about doing that graphically by drawing out a graph. Pretty nice, right? We're going to solve something graphically. We draw a graph. Seems intuitive enough. We need to label our axes here, our y and our x axes. Well, if we look, let's focus first on our constraints. There's two variables, x1 and x2. There's no x and y. So I want to label one axis x2 and the other x1. Now, for no particular reason, I'm going to label my y-axis x2 and my x-axis x1. And now what I need to do is to look at these constraints and to write them in the form of y equals mx plus b. So I see the first constraint. I can set x2 as y, so I just need to subtract x1 from each side. So with these three in mind, I'm going to rewrite these, solving for x2. So the first constraint, which is blue, is x2 is less than or equal to 200 minus x1. So how do I graph that out? Well, that looks a lot like y is equal to mx plus b. So when we look at this equal sign, less than or equal sign, we'll come back to that. So let's go ahead and draw this out. So we know it crosses the x2 axis at 200. And we draw, look at this, SU approved ruler. Check that straight line out. It's going to be at 200. Okay, now let's look at our second constraint. Our second constraint is 6x2 is less than or equal to 1566 minus 9x1. I divide it by 6 now, and x2 is less than or equal to, see if I can do the math on this, 261 minus 3/2 x1. Okay, so the y-intercept happens at 261, and it's going to have a slope of negative 3/2. So it's going to come down to about 175 or 174. So I'm going to draw that something like that right there. So this is about 174, and this is about 261. Okay, so now I have two constraints. Let's look now at our third constraint. Our third constraint was 12x1 plus 16x2. So I'll get 16x2 is less than or equal to 2880 minus 12x1. I divide by 16, so x2 is less than or equal to 180 minus 3/4 x1. So I graph that out. So the x2 intercept rather is at 180, and the other intercept on the x2 axis, I'll just put in 0 for x2, solve for 180, is about 240. So it looks more something like, let's see if we can draw this. Maybe not to scale, but we'll call it to scale anyways. So to 180. So now I've graphed out all three of these constraints. Now what you think about is what one is saying is that our x2 has to be less than or equal to 200 minus x1. So if the true value, or the x1, x2 that satisfies this, has to be less than or equal to this blue line. Well, if that's the case, once we add the second constraint, it also has to be less than or equal to the purple line. So if you look at this point right here, that point satisfies the first constraint. That is less than x2. x2 is less than or equal to 200 minus x1. But it doesn't satisfy our second constraint. So when we look at our feasible region, we want to identify the feasible region. as being less than or equal to all the constraints. So it's going to start right here on this corner, and the feasible region is going to slide down this red line until it reaches that point. And then it's going to slide down the blue line until it reaches that point, and then slide down the purple line. And therefore, this whole area is our feasible region. So it's the red line until we reach here, then it's the blue line, and then the purple line. All right. And so what we want to think about now is, well, what are the possible solutions? Well, the possible solutions we're going to think about are going to be here, 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 and here. So we call these points the corner solutions. And the extreme point theorem says that one corner will be the answer. So right now you're going to take that on faith, and when we come back in our next video, we're going to now incorporate the information we have on the profit function to help us see that. As of right now, we've just focused on the constraints. This next video is going to focus on the profits and how that incorporates into our constraints.